Hi friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know. Right? Okay. 1 second. Yeah. Hi brothers, I hope my voice is audible to you, isn't it? If my voice is audible to you, then please say hi. Vasant Sai, hi sir, hi. Hi Vasant Sai, is my voice is audible to you? Right? If my voice is audible to you, please say yes. Then I will understand the voice is audible. Okay, right. So if you people are in online, yes, yes, audible. Okay, good, Vasant Sai. Okay, thank you. And if you people are in online, please say hi so that I will understand like you people are in online. Okay, right. And before I start the session, just I want to mention one thing. Today onwards, we are starting RCC. So today's maybe 1.5 hour session or 2 hour session is completely on the fundamentals of RCC. Like what are the basic definitions that are required in the design of RCC, we will see, and basic fundamentals and basic fundamental problems like design strength, characteristic strength. Okay, design strength, characteristic strength. We will also work out the design, how to find out the design load. So what are the different design philosophies that we will use in RCC? I mean, what are the materials that we will use in RCC? What is the usage of different materials? So what is the length of diameter of the bars, reinforcing bars available in market? So out of different types of reinforcing bars that are available in market, which bar is very good? Which bar is very good nowadays? So all these fundamental things I can say we will discuss. Okay, right. And without these fundamentals, you cannot progress well in the actual sessions of RCC. So that's the reason why I want to take first the fundamentals, right? Okay. Kopala Kaushik. Hello, sir. Hi, Kopala. How are you, bro? ఎలా ఉన్నారు కోపల కౌశిక్? So hope you are fine. Okay. So before I start the session, I just want to say a very big hi to all of my brothers and sisters who are all on the online. I welcome you all to this India's largest online e-learning platform, Unacademy. uh, Before I start the session, I recommend you to install this Unacademy learning app. When you install this Unacademy learning app, so much free content is also happening in this Unacademy learning app. That is also for free of cost. You can even watch some of the free videos, many of the free videos in this app also. So that's the reason why I'm recommending you to install this Unacademy learning app from the Play Store. And moreover, you can follow me by using this link which is given here. If you press this link, it will redirect to my profile page, and you can follow me. When you follow me, there are three advantages are there. Already done free videos of mine in Unacademy learning app, free courses you are able to watch. Second thing, the upcoming free lectures of mine will be notified to you. And third, the after every free lecture we will provide notes in Unacademy learning app, not in this YouTube sessions. In app, generally we will provide the PDF notes. You can avail all these three if you are able to follow me. That is the greatest advantage. And if you are a serious aspirant of GATE and ESE Pro, then definitely I can recommend you to take the subscription. To take the subscription, you can get the subscription from Unacademy Plus, and you can use this code VT10 to get 10% discount. When you use this code, when you use this code directly, it will connect between you and me, bro. And after you install this Unacademy learning app, now you can keep the target. The target you can keep as GATE and ESE or any other competitive examination, other PSU examination. If you want to crack, you can keep the target as that. So whatever the maybe the examination you want to crack, you keep that target here, and and go to Unacademy Plus in that. And after you go to Unacademy Plus in the main menu, you can see this get subscription. If you press this get subscription, payment will be asked. When you use this code VD10, directly 10% discount will definitely come. Full series चलेगी क्या? Definitely brother, definitely here, definitely I can say full series chalegi bhai, right? So before I start, I just want to convey one thing. Some people will also ask us like, okay, Sir, what is please introduce about yourself first, right? Some people will also ask. I am Venkat Tilak Upalapati. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also. My background of education is completely into structural engineering. So here also in an academy platform, I am going to tackle only the structural subjects ranging from engineering mechanics, strength of materials, structure analysis, concrete structure, steel structure, and finally to construction materials and management. These are the topics that I deal. Right. In addition to this one, some people will also ask us, sir, what is your previous experience in addition to teaching? Previously, I worked as research scientist or research engineer in University of South Carolina for a funded project. For a funded project, I worked as a team lead, come research engineer also in USA. In addition to this one, previously I worked as head of the Department of Civil Engineering also for an engineering college. This is in India. This is in USA. That means I have both local experience and global experience in addition to teaching. Coming to teaching, totally I have 12 years of teaching experience in teaching GATE and ESE in different top coaching institutes all across India. Right. Some people will also ask us, sir, in addition to teaching, what extra thing that you will do? Because you are a civil engineer, now, generally people usually do consultancy. Yes, being a structural engineer, I personally do structural consultancy on my own. I provide structural drawings to my clients and I provide material testing reports to my clients. These are the two things generally I do, right? So anyway, I can say if you are a serious aspirant of GATE, you are free to use this code VT10 to get directly 10% discount on all the courses in Unacademy Plus. Okay, some people will also ask us, sir, you asked us to install the Unacademy Learning app. Now, how to install that one, sir? Because we don't know. I hope you know. Go to Play Store. I hope everybody of you Play Store in your mobile phone. Go to Play Store and in the Play Store type this name Unacademy Learning App. When you type this name Unacademy Learning App, this type of championship trophy type of app is appearing to you. Just install that one. When you install this one, a screen will get opened. I hope you are able to see a screen which is on the right hand side. In the right hand side screen, this is the target what you want to achieve. Keep the target as GATE and ESE or maybe the other competitive examination or PSU examination what you want to crack. And here in this main button, main menu, you can go to you can go to I can say Unacademy Plus. In this Unacademy Plus, and after going to Unacademy Plus, if you want to uh, purchase the paid course, use this code VT10. So get subscription, get subscription by using code VT10. This is what I can say. Some people say, sir, we are not able to pay, but I can say if you are into this paid system, definitely lot of support will come to you, brothers, and definitely if you follow that structured course, definitely you are going to get a good rank. We will ensure you that definitely. And some people will also say like, sir, we are not able to pay that much, and there are installment plans are also there, brother, like per month also you can pay. It's not at all a big deal and it's a simple amount only. And coming to, you can use this code to follow me. When you use this code, it will directly redirect to my page and you are able to follow me by using this link. And I can say this is one way we can say, right? Some people will say like, sir, after taking subscription, okay, what are the benefits that I will get, how I will be different when compared to free users, right? So the first and foremost advantage is instant doubt resolution is possible. So when you had taken when you had taken paid subscription, instant doubt resolution is possible. You can talk directly with the educator and the educator will resolve all your doubts through polls. So you can directly have a chat with the educator and make your doubts get resolved. That is the first and foremost advantage, in addition to daily live classes, right? And second advantage, in order to crack any sort of competitive examination, in addition to instant doubt resolution and lectures support, generally test series support should also be there. We are providing test series support with the in the help of live tests and quizzes, mock tests, daily bias tests, grand tests, and all this stuff. You will write these tests. After writing these tests, you will evaluate your performance, and you can compare your performance with the topmost students of an academy. And if you are lagging performance in some of the areas, you can improve your performance by working out more number of problems in that particular topic. And I can say by watching more number of videos in that particular topic, you can definitely improve your performance. That is the second advantage. Third advantage is there is no need to plan yourself. We will provide the entire plan. If you stick to that plan, and if you are able to work out the lectures and work out the tests, quizzes, and all the stuff according to that plan, definitely we are pretty much sure like you are able to get a very good rank in any of the competitive examinations. So that is all the structure, all the courses that are provided by Unacademy are completely structured courses, keeping in mind that even the below performed student is also able to cope up with our lectures. Just like with other platforms, we will not compromise with the number of hours here. That is the third advantage. And coming to the fourth advantage is, let us suppose a student is not able to come to live class on one day. He will be provided with the same lecture as a recorded version in recorded courses, maybe through mobile phone, or maybe through a PC, or maybe through any other device of his comfort. He is able to watch the same lecture for n number of times, right, depending on his subscription, maybe for 1 year duration or maybe for 2 years duration. For any of this, if you want to get any of the paid course, any of the paid course, not only in AC but from 6th standard to PG standard, any of the paid course, you are free to use this code VT10. Definitely 10% discount you are bound to get, brothers. And these are some of the topmost educators that we have. You can have a look directly in the app also. You can follow me by definitely using this link. Just click on this link, you are able to follow me. So this is the link. If you click here, you are able to follow me directly in the app. And these are, and you can see the courses will be taught separately in English separately, and also in the Hindi separately. Those guys who are good in Hindi, they will go to Hindi medium. Those guys who are good in English, they will watch English classes. So depending on your flexibility, definitely you can watch whatever may be the courses of your interest. Dim Shiv, sir, I am your student. I miss you. No one is better than you in that platform. Okay, Dim Shiv. Okay, thank you. Okay, thank you. Okay, right. Okay. Anyway, I'm here now. You can follow me. It's not at all a problem. Dim Shiv, I am always with you. So don't worry, brother. Right. I just want to convey one more thing also. So, brothers and sisters, two things are happening here in this platform. Separate classes for English medium students, separate classes for Hindi medium students. So I request you, if you are a Hindi guy student, you go to Hindi classes. If you are an English guy student, if you are good in English, you come to English classes. So that's how you can easily tackle all the things. So when you had taken subscription, you will be provided with classes of both English medium and also in Hindi medium also, right? Yes. I just want to convey, especially our brother Dim Shiv will also ask us, sir, till now in GATE and ESE, how many classes you people, how many courses you people had provided, especially in civil engineering, especially in civil engineering in GATE and ESE, we had provided 7 courses, brother. I mean 8 courses. Out of these 8 courses, few courses are in English, few courses are in Hindi, and out of these 8 courses, I can say few courses are long-term courses, few courses are short-term courses or crash batches. So as every month, one more course will also get add up. A pool of faculty are going to get add up day by day or by month. You can expect more number of courses. When you had taken subscription, you will be given access to all the courses that we had launched in that particular stream. Please understand, you are not given only access to one course. You will be given access to all the courses that are launched in that particular stream. That is the biggest advantage here. And anyway, if you want to get 10% discount, you can use this code VT10. And I just want to convey one thing. All the topmost educators of India are directly available to you right now in this Unacademy learning platform. There is no need to go to Delhi. There is no need to go to Bombay. There is no need to go to Hyderabad also. With the help of single click by the usage of single code VD10, and by taking paid subscription, all the doors and windows of Unacademy are open, and you can have direct, you can learn all the complete courses from the India's topmost faculty pros, right? So coming to the financial terms. So coming to the financial terms, if it is a 12 months course, for 12 months course, after 10 percentage discount, if you are able to use this code VT10, we are going to give it for you by 27,225. If you are a student of third year or maybe second year students, then I can definitely recommend you this 24 months course. This 12 months course I can recommend if you are a student in final year, right? And for 18 months the charge is 34,650 after 10 percentage discount. If it is a for 24 months course, after 10 percentage discount, the cost is 39,600, right? Shabin Sahiluddin, I will take ILD maybe just after the completion of this what you call this RCC, brother Shabin Sahiluddin. Okay, right. So please excuse me. I will take definitely. So within 1.5 month, I will try to complete your syllabus. Don't worry, 1.5 months, at max 2 months. I will complete all the what you call I can say all the syllabus of entire structural engineering. I will complete. Okay, right. Shabin Sahiluddin. Right. And I already want to convey, we already started 3 new batches. You every day my class is happening definitely by 11 a.m. So please take that advantage, and please take the advantage of other faculty also, and learn from them. Okay, right. So anyway, I just want to convey, we already started a Telegram group, and the name of the Telegram group is Unacademy underscore Civil Engineer Tilak. You come down to this Telegram group. If you had any doubts, you can post your doubts directly in that Telegram group. I will respond to your doubts definitely if it is a structural doubts. If it is a non-structural doubts, non-structural engineering subjects, the other faculty who are on that platform will definitely respond to you. Sir, yes, yes, definitely, definitely. Will you please complete the important topics for GATE? Definitely, Demons, definitely I will complete the important topics for sure. No doubt at all. No doubt at all. Within 1.5 month, I will complete. Here, I mean, from the past 2 months I completed even in app. If you see, if you refer to app, and also in YouTube together, I completed structural analysis. I completed steel structures in both the stuff. Okay, so you can take use of the lectures even also in app. Okay, please use that app also, right? Right. So shall we start the session? So before I start the session, I just want to say, okay, some people will cry at me like why these fundamentals are required. But without fundamentals, sorry about that. But without fundamentals, you cannot progress well. Na? So that's the reason why I thought like let me take a fundamental session on reinforced cement concrete. Okay, what is this reinforced cement concrete? Reinforced cement concrete is a material which is composed of reinforcing steel. One second, which is composed of reinforcing steel, and I can say, and cement concrete. So it reinforced concrete. It is one second, brother. Reinforcing concrete. It consists of. I don't know. Arey yaar, what happened with this? Reinforcing steel. Okay, 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 okay. Reinforcing steel, and I can say cement concrete is also there, right? I don't know why this pop-up is coming. So reinforcing steel and cement concrete. Okay. Now the question is, sir, reinforcing. What is called as reinforcing steel? Steel which is used as a reinforcing material in concrete in tension zone. Generally, that steel in concrete is called as reinforcing steel. Now, especially in cement concrete, what are the compounds that are there? Please excuse me. I don't know why this pop-up is coming. Wait a second. Please wait a second. And why this pop-up is coming? Right. Okay. Some people will also ask us, okay, sir, in this cement concrete, what are the constituents of cement concrete? I hope you know concrete is a mixture of combination of cement, coarse aggregate, fine aggregate, and water. What is the major role of cement in concrete, man? Cement will act as a binding material, and this binding, why it is acting as a binding material? Because of the production of the calcium silicate hydrate gel product, because of which it will bind the coarse aggregate and fine aggregate particles together. What is the reason, what is the strength behind this concrete? The strength in concrete in coarse, the strength in concrete is given by the ingredient called as coarse aggregate. So how can you define a coarse aggregate? A coarse aggregate is a material for which is having a size which is more than 4.75 millimeter and less than 80 millimeter. Such type of such type of material is nothing but coarse aggregate, which will give you strength for concrete. And what is the advantage of this fine aggregate? The advantage of fine aggregate is a void filler. I hope you know what is a fine aggregate. Fine aggregate is the material which is having the size less than 4.75 millimeter and greater than 150 micrometer. So such type of material is nothing but fine aggregate. The major advantage of this fine aggregate, it will fill, the fine aggregate will fill the voids created by coarse aggregate. So that is called as a void filler. And moreover, I hope you know the problem of shrinkage, right? Dear Dhiman Shiv, especially, maybe I can say, 1 second, go here, use this, I mean, use this link, brother. Dear brother, use this link. The link is given here. Okay, use this link. Okay, use this link. Just press this link. It will directly redirect to my profile. Okay, if you don't know about that one, brother, in such case, how to follow me is, another thing is, here go to free classes. In the drop down menu here, go to free classes. After you go to free classes, here in the search button, you type my name, complete name. Go to free classes and type my name. Okay, don't go to plus and type my name. Do you go to free classes and type my name, Venkata Tilak Uppalapati. Then definitely my profile is visible to you. Or else the best way is use this link, brother. This is the link that I had provided to you. Just use this link and press that link. Okay, then definitely you are able to see my profile. Okay, right. Sorry about that one, man. So just to respond to a guy, I went there. Okay, so please excuse me about that, right? Okay, one thing. So what is the use of this fine aggregate, man? I hope you people know about shrinkage now, bro. So the shrinkage is a bad thing in concrete. So because of which cracks in concrete will possible, because of evaporation of moisture from concrete, the cement concrete will shrink and it will get cracked, right? And there is a reduction in the volume of concrete is possible because of shrinkage, because which results in cracks, obviously. So to reduce shrinkage, to reduce shrinkage, uh, the fine aggregates are useful. The fine aggregates will reduce the shrinkage in concrete, or I can say in cement mortar also. So what is the usage of water? Concrete is a mixture of all these four, na. So what is the usage of water? Water is useful for making hydration of concrete. So generally for the if we supply water, generally that that cement can react with the water, then it will produce this binding products. The binding products called as calcium silicate hydrogel, whatever that may be. So for the hydration purpose, water is required, and also to achieve desired workability, also water is required. So if I increase the water content, definitely the workability of that concrete will also get increased, definitely, right? Okay, these are the basic constituents. What are there in reinforced cement concrete? Now the question is, some people will also ask me, sir, okay, why the reinforcing steel is provided in cement concrete, sir? Why can't I directly use this plain cement concrete? Why I am using reinforced cement concrete? Maybe the question is, maybe let me rub. Why only RCC is used? Why only RCC used instead of plain cement concrete? What is the answer generally you can provide? The major problem with respect to concrete for plain cement concrete, PCC for plain cement concrete is less ductility and weak in tension, or I can say zero tensile strength. If you want to evaluate the tensile strength, almost some value which is very less, 0.7 times of root fck, that is the tensile strength of concrete, which is very less, right? So as the concrete is weak in tension especially, so the tensile stresses must and should be resisted by concrete. In such case, how the concrete can resist tensile stresses? In the in tension zone, if I am able to provide reinforcing steel, so in tension zone of concrete, we provide with steel, man, reinforcement steel as a reinforcement to resist tensile stresses. And moreover, that is the major problem with plain cement concrete is that. What is the second major problem with plain cement concrete? The failure of concrete is a sudden one, right? So it is a sudden failure, I can say. So maybe I can say here, sudden failure, or people usually call it as catastrophic failure also. Catastrophic. If any structure will fail sudden, let us suppose you are staying inside a structure. Okay, let us suppose the structure is having only compressive stresses are possible throughout the life. You had constructed the structure with the help of only plain concrete, pure concrete. Okay, no reinforcement is there. If the failure in that structure is happening, that failure is very sudden. By the time you are coming outside the structure will collapse and we will lose our life, right? The persons who are staying inside the structure will lose their life. So definitely, in order to stop that sudden failure, I need to change something in this plain cement concrete. So how I can achieve ductility or warning nature in that plain cement concrete? By the addition of this reinforcement steel as reinforcement, if I provide, then definitely that will increase ductility, that will improve that will improve warning nature, before failure. When it is, let us suppose, when heavy earthquake has got hit, in such case the structure will fail, no doubt at all. In such case, when it is providing more warning, in the meantime the persons who are inside that structure can come out, all those lives will be saved, which is a good thing, right? So in addition to strength parameter, even ductility parameter is also very much required. The ductility in plain cement concrete can be achieved by the usage of this steel as the reinforcement. So that is the biggest advantage, brother. So that's the reason why instead of going for plain cement concrete, we will go for reinforced cement concrete, right? So generally for any structures, definitely in addition to compression, tensile stresses will also coming to picture. Definitely, even though if you apply compressive nature, but because compressive stresses also, but because of moving loads, or because of dynamic loads like wind loads and earthquake loads, on the same phase reversal of stresses are possible, and I can say both compression and tension are possible on the same phase, definitely. So in such case, plain cement concrete is not worthy. Definitely only reinforced cement concrete is worthy in such cases, right? Now the question is, sir, okay, you mentioned steel as the reinforcement. What is the type of steel bars generally that are available in the market? The type of steel rods that are available in market are well, I mean reinforcing steel. I just want to say there is a lot of difference between structural steel and reinforcing steel. Here I am talking about reinforcing steel. Please understand, this is reinforcing steel. This is not structural steel. Structural steel is a different. Structural steel only as a structural element, like I section, maybe channel section, or steel only as a structural element. That is structural steel. Here the steel is used in association with concrete. So that's the reason why steel is used as a reinforcement in concrete. That's the reason why this steel is nothing but reinforcing steel. Maybe let me write here reinforcing steel. So coming to this reinforcing steel, you tell me how many steels are available in market, bro. The steel that are available in market are they're generally I can say in two ways. One is mild steel and second one is HYSG steel. So mild steel doesn't have any sort of rips or what are these are called? These are called as rips or corrugations, which generally HYSD bars generally will have. In case of mild steel, generally this mild steel doesn't have any sort of rips, it is plain. So I can say mild steel the mild steel is plain, I can say. For mild steel only it is available from 6 millimeter only, from 6 millimeter diameter it is available in market. Only from 6 millimeter the diameter it is available in market for mild steel. And I can say majorly this mild steel is used as a stirrup reinforcement. I hope you know stirrups or shear reinforcement, because the shear reinforcement, if I use this as shear reinforcement, this will provide more warning nature before failure, especially in case of earthquake zones. The major failures are happening at beam column junction, that too especially because of high shear forces. That's to tackle those high shear forces, high ductility and everything. Generally this mild steel is far better when compared to HYSD steel, especially in at beam column joints, especially in the form of shear reinforcement. Sir, what are the use of these corrugations? These corrugations, I can say, these corrugations are rips. These rips will bind with the surrounding will bind with the surrounding concrete and will not fail in bond, and will not fail in bond, just in order to say to be stay free from bond failure. These corrugations are required. When these corrugations are there, when these rips are there, when these corrugations are there, the bond strength of that concrete will bond strength between that steel bar and that concrete will be high. So generally for HYST bars I can say bond strength is high. If you take mild steel bars, its flexural strength is high, its shear strength is high, but its bond strength is but its bond strength is less. That is the disadvantage with mild steel. So that's the reason why for main bars, if you see, we provide HYSD rods, because in addition to flexural strength, even bond strength is also required, right? So this bond strength is very good in case of HYSD bars, dear Shabin Sailuddin. Right. Now coming to the diameter of bars, diameter of reinforcing steel that are available in market are ranging from 8 millimeter is the minimum diameter of HYSD bar that is available in market, and 10 millimeter, 12 millimeter, 16, 20, 20, 25, 32 and 36. Why HYSD bars are not used in stirrups? Dear, HYSD bars are not used in stirrups because in case of stirrup, what is stirrup? Stirrup is used for shear reinforcement, right? For shear reinforcement. In case of shear reinforcement, especially by the time of earthquake zone, dear Jabin Sailuddin, the major possible failure at beam column junction is majorly by shear, just to ensure high ductility, to ensure high ductile failure in shear zone, because the failure will happen in shear mode, because to ensure more ductile failure in shear zone out of mild steel and HYSD steel, mild steel has got high ductility. Whereas the disadvantage is the HYSD bars is low ductility. Even the strength is high per HYSD bars, but still its ductility is low. But here in case of earthquake zones, the major failure is at beam column junctions where I need to ensure ductility. Ductility is the requirement for earthquake resistance. So let it shake, but it should not break. Let it break at a very higher seismic at a very higher seismicity, but it should provide warning. To achieve sufficient warning, we need to use this mild steel stirrups. Is that okay, dear Shebin Sailuddin? To achieve high ductility in shear zone, especially in earthquake regions. Generally, we provide this mild steel. I hope you might had listened. I hope you might had already come across. Can I rub the screen? I just want to say, in this mild, this is mild steel. This is HYSD steel. Here carbon content will lie between zero point 0.1 to 0.25 percentage. Here carbon content will lie from more than 0.25 to 1.5 percentage here. So here as carbon content is less here, less carbon content, high ductility. Here high carbon content, low ductility. I hope you might had already studied this basics in your material side, right? Okay, right. So out of these are the things that are directly available in market, right? Now some people will also ask us, sir, these are the bars, mild steel bars and HYSD bars. Okay, you tell me what is the diameter, what are the properties of the steel? Is the properties of the steel is different for mild steel bars and HYSD bars? No, the properties of steel are one and same for mild steel bars and HYSD bars. Properties in sense material constants, like material constants for steel. Material constants for steel. Some people will also ask me, sir, what are the materials constants for, I can say, concrete, sir, because this is an RCC, na? So, okay, let me write material constants for concrete. Young's modulus of concrete, it will vary with respect to grade. So, short-term Young's modulus, it is equal to, definitely short-term Young's modulus generally we will use in elastic stage, which is equal to 5000 root FCK. And coming to alpha, coefficient of thermal expansion of concrete, alpha of concrete is same that of alpha of steel, which is 12 into 10 to the power of minus 6 per degree C, right? So mu is coefficient, mu is Poisson's ratio of concrete. Poisson's ratio of concrete, if you see, its value will range from 0.15 to zero point 0.2 generally. 0.15 to zero point 0.2. Generally, if you see, our STAD program will generally take a mean value, just 0.17 is the value taken care by STAD programming. I hope you know programming made by STAD. In that one, the mu of concrete is taken as 0.17. And density of concrete, everybody knows, like density, I mean weight density of concrete, gamma of concrete. Maybe if it is plain cement concrete, it is 24 kilonewton per meter cube, PCC. If it is RCC, it is 25 kilonewton per meter cube. So, but the question here is, okay, sir, these are the material constants. Generally, we will use these constants are helpful by the time of analysis, especially in strength of materials. Okay, by the time of working out the self weight, these constants are required. Okay, now the question is, sir, what is the length of steel bar? What is the length of steel bar? I can say reinforcing bar, not steel. I can say reinforcing steel bar. Reinforcing steel bar. What is the length of reinforcing steel bar that are available in market? The length of reinforcing bars that are available in markets are 12 meter. This is standard. standard length of reinforcing bars available in market is 12 meter if the diameter of the bar is up to 25 millimeter dia. So if phi is less than or equal to 25 millimeter, the length of the rod directly available in market is 12 meter. If the diameter of the bar available, if the diameter of the rod is more than 25 millimeter, in such case the length of the rod available in market is 6 meter. Right, these are the standards lengths of bars that are available in market. People say like, sir, what is the length of the bar? There are two cases. You should say, sir, there are two cases are there. The diameter is less than or equal to 25 millimeter, then the length is 12 meter. If the diameter of the rod is more than 25 millimeter, in such case the length of the rod available in market is 6 meter. Like that you need to mention correctly. Some people just by asking, the people will say 12 meter, but it is not the correct answer. There are two conditions are there separately. Is that okay? Right. Some people will also ask us, sir, okay, this is fine. Now you people tell me, nowadays, out of this nowadays, nowadays we are not listening to this word HYSD bars, sir. The name of this HYSD bars is high strength deformed bars. What is the disadvantages in this HYSD bars? I can say the disadvantage with HYSD bars is less ductility, right? The disadvantage with this bars is less ductility. That is the disadvantage. So because of the disadvantage, nowadays a new technology has came. The technology is called as thermomechanically treated bars. Thermomechanically treated bars. Nowadays we are using this TMT rods instead of this HYSD bars. So coming to this TMT bars, how I can say? So I can say we will take a mold containing molten steel. The molten steel which is kept in the mold is immersed in cold water. Is immersed in cold water. When it is immersed in the cold water, outer surface layers has got cooled, but I hope you are seeing this inner core. This inner core will not get cooled. Outer surface has got cooled very much, but as the inner surface doesn't has got cooled much. So as the inner surface doesn't has not got cooled much, I can say the core in the inside core is ductile. Inside core is ductile and tough. Inside core is ductile and tough, so which is responsible for ductility, whereas outer surface is hard. Why the outer surface has become hard? Because outer surface has got cooled very much. The outer surface will become hard and resistance to weathering, resistance to scratching and all this stuff. Hardness will be there for the outer surface, whereas the inner surface is more and more softer. Outer surface is more and more harder. So this type of bars is a combination of outer layers are more harder, inner layers are softer. In this case, to achieve ductility is achieved by this inner cores, whereas strength is given by this outer layers. So that's the reason why I can say for this thermomechanical bars, I can say nowadays this HYSD bars are replaced by this TMT bars because of higher ductility, especially for this TMT bars. High ductility is also possible. So because of that greatest advantage, nowadays these HYSD bars are replaced by TMT bars. Some people will also think, sir, there may be some chemical composition change may be there between TMT bars and HYSD bars. No, the chemical composition of TMT bars and HYSD bars are one and same. There is no change, but only the change is how they are subjected to quenching. That is the only difference. Because of this quenching difference, this TMT bars are subject. The TMT bars has got high ductility here. Prithvi Reddy sir, which subjects you are going to teach in this platform? Dear, I am going to teach only structural subjects ranging from engineering mechanics to till construction materials and management. All the 6 subjects of structural engineering program, only structures. I teach only structures. Other than that, I won't teach. Okay, right? Only structures. Right, right. Now, some people will also ask us, sir, okay, out of these methods of, sorry, now there are different methods of design are there, and maybe nowadays you might had seen even here also, out of bars FE 500, they may use the terminology D, FE 550 D. So what are this D stands for? D stands for ductile. D stands for ductile bars. So likewise, these ductile bars of the TMT rods are available. Right. Now, some people will also ask us, sir, okay, uh, in this in this methods of just this is an introduction session, na? So how many design philosophies of RCCs are there? So what are the different philosophies of RCC, right? So maybe what are the ways how we can design an RCC structural element? Maybe I can use three different methods. One is working stress method, second one is ultimate load method, and third one is limit state method. So out of these three methods, right now till today we are, I mean, these days we are using only this limit state method. This limit state method is more advantageous than these other two methods. Okay, this is we are using nowadays these nowadays we are using this uh, this design philosophy. Methods of RCC design, or in other words, we call the same thing as design philosophies. So what is the so coming to working stress method? Okay, I just want to give what is the difference between these three, and out of these three, I just want to convey this limit state method is superior. Why this working stress method is not superior? So what are the terminology generally we will use this working stress method? All these things I want to tackle. So coming to this working stress method first. So working stress method, another name for this working stress method, it is also called as elastic method, or it is also called as factor of safety method, or maybe elastic method, or we can say modular ratio method. So different names are there. So in any method, I just want to convey, I will compare all these three methods with respect to the for what load we are designing the structural elements. What is the design strength? I want to compare these two in terms of all these three methods. What is the design load generally? For what load we will design the structural elements, especially in this working stress method? In working stress method, what if this is the structural element? What is the actual load that is coming on the structure? If this is the actual load that is existing on structure coming actual load that is existing on structure, actual load that is coming on structure, the same load we for the same load we will design, for the same load we will design the structural element. So the design load is also called as working load or service load. So how can you define working load or service load? How can you define working load or service load? So working load or service load, it is the actual load that is coming on the structure is nothing but working load, working load or service load. This is the factual or actual load coming on structure as it is. That is nothing but working load. So the actual load means it will include wind load and earthquake load. So it may include wind load, earthquake load, whatever that may be. What is the load that is coming on the structural element? So without exaggerating the load. Here the load is not exaggerated. So let us suppose my load. Let us suppose the beam self weight is, for example, 100 kilonewton per meter. The live load coming on the beam is 100 kilonewton meter. So we will take the design load as 100 kilonewton per meter only. We will not exaggerate that load. Generally, in case of limit state method, we will exaggerate the load that is coming on the structure, because of maybe I can say like future extra loads may come into picture, because of heavy loads may also come into picture, or maybe uncertainty in loads are possible. Because of that design philosophy, especially in limit state method, we will exaggerate the load that is coming on the structure with the help of load factor, or maybe partial safety factor for load, and we will increase the load coming on the structure. But here in case of working stress method, whatever may be the actual load that is actually acting on the structural element, the same load we will use as the design load. For that load only we will design the structure. Yes. So here I can say design load, I can say, is not exaggerated. It is the actual load is taken as the design load. Okay. So coming to, so this is about design load. Coming to design stress. So what is design stress? How another terminology called as design stress, or allowable stress, or permissible stress. What, how we can define this design stress, or allowable stress, or permissible stress? So generally for the design purpose, if the if the if my if I am a material, if I am able to lift 100 kg, but in calculation purpose, generally in calculation purpose, for the for to account for safety, the load carrying capacity of me will be taken as not 100 kilonewton, less than 100 kilonewton generally. So let us suppose if the actual resistance of the material, the actual strength of the material is characteristic strength of the material, is the actual failure strength of the material. What is characteristic strength of the material? Actual failure strength of material. If I take the actual the failure strength of the material, then there is a chance like then there is a chance like I can say I cannot take any chance like if more load can come, then there is a chance like it may fail fast. So maybe because of moving loads especially. So I don't want to take any sort of chance. I need to underestimate the strength of the material. So here also in design stress, we are underestimating the strength of the material. Design stress is equal to actual strength of the material, or characteristic strength of the material, divided by factor of safety of material, divided by factor of safety. So how you can define the characteristic strength of the material, brother? So here design stress I can say simply is underestimated. Maybe I can say clearly here. Maybe let me write here. Let me change with the color. Ink. I'm changing the ink. This design stress is underestimated. If the strength of the metal is underestimated, that is fine, it will provide safety. Okay, right. So as the strength of the metal is underestimated here, with the help of factor of safety, that's the reason why this method is also called as factor of safety method. Using this factor of safety, this factor of safety is used only to reduce the strength of the material, not to increase the design load, right? So now the question some people will also ask us, sir, these are the two things, okay, so but what is the reason, what is the reason behind why we are not using this working stress method? The major disadvantage is the load is not exaggerated. So whatever may be the actual load, the same load we are using. If there is a, if you had made any miscalculation in loads, right, so there is a chance like wind loads and earthquake loads, sometimes extra loads can also come. The load calculation, especially this earthquake load, which is generally based on generally not very much precise. So in such cases some extra loads are coming into picture. In such case this design philosophy is not that much worthful, right? So that is the greatest disadvantage. Some people will say like, sir, okay, out of this characteristic strength of a material, how can I work out characteristic strength of a material? For example, so if I say m20, Why, if I say M20, what is the characteristic strength of this material M20? FCK. FCK is the characteristic strength of this concrete, which is 20 megapascal. 20 megapascal. This is characteristic strength. If I say Fe250, for material Fe250, what is the characteristic strength? The actual failure strength is yield strength, which is 250. So characteristic strength in layman language, we can call it as actual failure strength of material in lab testing. Sir, only strength is underestimated and no load is underestimated. Yes, only strength is underestimated. The load coming on the structure should be overestimated, right? That is a good design philosophy, right? So I can say, coming to the factor of safety. So coming to the factor of safety in beams for flexural members, what is the factor of safety in beams for concrete and steel, brother? For concrete, what is the factor of safety, brother? The factor of, I hope you are able to see here clearly. Design stress is equal to characteristic strength of material by factor of safety. So what is the design stress for M20 concrete? Design stress for M20 concrete is 20 by 3 here. For concrete beams, for concrete factor of safety is 3. For steel, the factor of safety is 1.78. Some people will cry at me like, no sir, the factor of safety for concrete is 1.5. The factor of safety for steel, for reinforcing steel is 1.15. Brother, that is for limit state method. I am talking about the factor of safety in terms of working stress method. This is the old method. Okay, please understand. So what is the disadvantage in with respect to this working stress method? The design load is not exaggerated. That is the greatest disadvantage. In working stress method, design load is based on uniqueness theorem. What is based on uniqueness theorem means? So whatever actual load we consider that, so we can call, if the load is following, what is the load that is coming on the structure, that then we can say it is nothing but the design load is following uniqueness theorem. I can say design strength of the material, this is lower bound. Forget about this lower bound. I can use three words: underestimated. Underestimated means that material or that method is following, lower bound theorem. Lower bound theorem, right? If I can say exactly estimated, exactly estimated, I can say that material or that method is following uniqueness theorem. If I say, if I say overestimated or exaggerated, maybe I can say overestimated or exaggerated, then I can say that material or that method is following upper bound theorem. These are technical words, nothing else. Upper bound theorem means it is overestimated. Uniqueness theorem means the load or that strength, whatever that may be, is exactly estimated. Lower bound theorem means it is underestimated. Like that we can mention. Right. So what is the major disadvantage with respect to this working stress method? Disadvantage. What is the greatest disadvantage is? Can you mention what is the greatest disadvantage? The load coming on the structure is not is exaggerated. So the design load is taken as it is. The design load is taken as it is and it is not exaggerated. So design load is not exaggerated. And second disadvantage is, there is no guidelines how to improve the lifetime of this structure, especially by using this method of working stress method. But whereas in case of limit state method, so many guidelines were there how to improve the lifetime or durability of this structure, but there are no guidelines were there how to improve the durability or lifetime for this structure. There are no guidelines on serviceability aspects by using this working stress method. So in this method, serviceability is not considered. Serviceability of structure is not addressed. Serviceability of structure is not addressed, is not given. That guidelines were not given. So these are the two things which are making us not to use this working stress method. And moreover, in working stress method, the factor of safeties for the material that were used are very high, which are not very much realistic. And moreover, this working stress method, by using this working stress method design, the section sizes generally we will get are very high in size, which are uneconomical also, right? I can say third disadvantage is this is more uneconomical also, right? Now because of this first disadvantage, there is an another what you can say, another design philosophy has came into picture. What is that another design philosophy? The another design philosophy is the ultimate load method. In this method, generally the design load is exaggerated, or design load is increased. The another name for this design load is called as ultimate load or collapse load. Here in the ultimate load method, we call the design load as ultimate load or collapse load. How we can work out that ultimate load or collapse load? It is equal to working load or service load. So the actual load that is coming on the structure multiplied by load factor, right? Some people will also call us, or from where I can get this load factors. The load factors depends on load combinations, and these load factor values are already given there in IS 875 part 5 for different load combinations. What is the load factors generally we need to consider that were there in IS 875 part 5. So please keep that aside, right? Now here the design load is exaggerated, there is no problem in that one. Coming to the design stress, what is the name for the design stress in this ultimate load method? Coming to the name for design stress in ultimate load method is design stress, and another name for design stress is called allowable stress, limit allowable stress or permissible stress. So these are the three names that we can use in ultimate load method. So how you can define this design stress? So here also one and same, characteristic strength of the material by material safety factor. I hope you had used the same terminology here. Characteristic strength of the material by material safety. Here factor of safety. Here we are using the terminology called as material safety factor. Characteristic strength of the material divided by material safety factor. So material safety factor is a synonym word for material safety factor is a synonym word for factor of safety for material, right? Right, factor of safety for material, right? So both, I mean, in different methodologies, I just want to say the terminology is some bit different, but the synonyms, I mean, the meaning is one and same, brother. The meaning is one and same. But in working stress method we call that as factor of safety, but in ultimate load method we call that as material safety factor. Both are one and same. Now here in material safety factor for beams, now everybody will call us, sir, what is the material safety factor for beams, especially for concrete, how much it was given, especially for steel, how much it was given. For concrete, material safety factor in beams, I just want to convey this. I hope you know, for concrete it is 1.5 is the material safety factor. For steel it is 1.15. So like this, definitely these material safety factors are just like that of this material safety factors are just like that of partial safety factors, just like that of limit state method. So here in this case, design load is exaggerated, design stresses are underestimated. I can say, okay, one second. Design stresses are maybe underestimated. So this is good. This is also good. But why we are not using this ultimate load method? Because in this ultimate load method, there is no guidelines for serviceability criteria was given. No guidelines how to achieve durability for this structure, how to achieve longevity for this structure, how to achieve serviceability for this structure. No guidelines were there to achieve durability for the structure was given in this particular ultimate load method. That's the reason why it's a failure. Else we could have used directly this ultimate load method. The upcoming limit state method is an extension of this ultimate load method, right? So I can say here, right, in ultimate load method, I can say the design load is based on upper bound theorem, and strength of material is based on lower bound theorem. So design load is exaggerated, I already mentioned, exaggerated, whereas strength of the material is underestimated. Both are okay. Why it is not becoming popular in this method? Serviceability is not considered. That's the reason why we are not using even this this particular ultimate load method also. Right, now coming to the third method, which is called as limit state method. Nowadays we are using that limit state method. Okay, one second. Nowadays we are using that limit state method. So okay, in this limit state method, so what is a limit state here first of all? So one second. The third method here is limit state method. Maybe let me limit state method. So first of all, some people will also ask us, sir, before you start limit state method, first of all, you define what is limit state. So let me define first what is limit state. Then I will start teaching you what is limit state method and all this stuff. Limit state. How can I define limit state? Don't think it is something. Limit state is a condition. I can say, I hope you know a condition. Limit state is a condition just before collapse. Till that condition, the structure is able to resist all the loads that are coming on the structure, and the structure is able to perform very well in terms of strength and in terms of serviceability also. That condition is nothing but limit state. So I can say limit state uh, is a condition just before collapse. Just before collapse, it is a condition. Up to that condition, the structure is able to resist all the external loads that are coming on the structure, right? So I can say up to this condition, up to that condition or this condition, the member or the structure, I can say member or structure is safe to resist the external loads, and in addition, it also not only resists the external loads, and the structure will also gives proper service throughout the lifetime, and also gives proper service throughout its life. So there are two things in limit state. There, I hope if you see here the definition, able to the member is able to resist the external loads. That is extra safe to resist external loads. That is one thing. And second highlight I can want to say is, and also gives proper service throughout its life. These two are the headings I want to convey. What do you mean by the structure is safe to resist the external loads? That means in limit state there are two states are there. One limit state deals with the structure is able to resist the applied loads, which deals with the strength aspects indirectly. So safe, maybe I can say safe to resist external loads means strength parameter. Can I say that one? This is strength parameter. And there is another thing is there, and also gives proper service. Uh, Proper service. This is one keyword. Maybe I can say another keyword. Maybe I can say that proper keyword, proper service throughout life. What is the concept, what is the limit state which deals with proper service throughout its life? It deals with limit state serviceability aspects, I can say serviceability aspects. So in limit state, there are two limit states are there. Limit state of strength parameters and limit state of serviceability parameters. Another name for limit state of strength parameter, we can call it as limit state of collapse. Right? Can I use this one? Sir, proper service means here shape in within. Proper service, maybe I can say proper service. Maybe I had already teach you. Like maybe proper service throughout its life means serviceability aspects. Like you can see, and the structure after construction should not have too many deflections, too many vibrations. Let us suppose you can take a structure. If the on the structure, if we people are moving, if the structure is not collapsing but the structure is keep on oscillating like a uh, a wave or something like this, in such case, do you stay in such type of structures? Do you travel over such type of structures? Psychologically some feeling will come. Like serviceability aspects deals with, I can simply say serviceability aspects are those aspects which deals with the lifetime, longevity, durability of the structure, which deals with the durability aspects of the structure. Simply I can say, which deals with durability aspects of structure. To deal with durability aspects of structure, these six are required. Of course, we will talk about that one. Right, the structure should not even the loading is applied on the structure. The structure should not make so many amplitudes. No resonance should come on the structure. Right, the cracking should be very very less. There should not be cracking on the structure because of the service loads. There should not be any excessive vibrations in the structure after the structure has got constructed throughout its life. There should be sufficient fire resistance should be there for the structure. There should be guidelines. There are guidelines for there should be guidelines how to improve fire resistance for the concrete structure. Such guidelines should be there, and I need to follow that guidance. There should be some guidelines how to improve the durability, the longevity, the lifetime of the structure. Yes, the all these comes under serviceability aspects. Simply serviceability aspects deals with durability aspects of structure. Do you understand the durability aspects of structure? Maybe if you don't understand durability, I can say durability means I can say simply longevity, lifetime, longevity of structure. Hi Devakar. Right, longevity of structure. Right. Yes. So this is about limit state of service good. But let me start. There are two types of limit states are there, right? So coming to, can I rub the screen? Two types of limit states are there. Limit state dealing with strength parameters. Limit state dealing with durability aspects, right? So maybe I can say, can I rub the screen? So limit states are divided into two limit states. One is limit state of strength aspects, like limit state of collapse, I can say limit state of collapse. And second one I can say is limit state of serviceability. In limit state of collapse, That means the structure should not fail. The structure should not fail means limit state of collapse deals with indirectly this parameter limit state of collapse deals with strength aspects, right? Isn't it or not? So can I write here directly strength aspects? Right. Shabin Sayluddin, sir, theory about mean and compressive strength. Here I will talk. It will come definitely. The theory about mean strength, compressive strength, what is characteristic strength, how to define characteristic load, what is characteristic strength. So what is all these definitions will also come. Please, but please allow some time. Okay, right. In limit state of collapse, I can say one is the limit state of flexure, bending, right? The structure should not fail in excessive bending moment. The moment of resistance of this section should be higher than the maximum bending moment that is developed on the structure, right? That is developed in the structure. That deals with there should not be no flexural failure, which deals with limit state of flexure, limit state of shear. Where this limit state of flexure failures will come, brother? Limit state of flexure failures will come, will takes place in beams. Limit state of shear failure will takes place also in beams. Limit state of, I can say, compression, where you can see about limit state of compression, where the compression failures are possible. The compression failures are possible in case of columns, I can say, in case of columns. And maybe I can say the fourth one, it is limit state of torsion, where torsion is possible, man. Torsion is possible in case of end beams or L beams, right? I can say clearly here, uh, maybe end beams, end or L beams. If you take any plan, especially if you take a plan in this way, generally, if these are end beams, these end beams, these end beams are definitely subjected to torsion. So which we call end beams are generally, these are taken as L beams also, or I can say beams curved in plan. How can collapse will occur due to torsion? Sir, how collapse can occur due to torsion? Because generally, dear Shabin Sailuddin bro, if you take an element, maybe this is first member, uh, because of this torsion, what how this torsion will develop? So because when you take a member here, this is member one, how the load is there on this member one, this is how the load will be there. This much of slab area will directly come on this first member, right? The load is on this side. When the load is on this side for this member one, uh, the reaction of the this is the applied load P. There is an eccentricity between the plane of loading. This is the plane of loading. This is the CG of the member. Between these two, there is eccentricity. So this member one, this end beam, is subjected to torsion. When this end beam is subjected to torsion, so because of torsion, what sort of stresses will develop, brother? Because of torsion, I hope you know from the fundamentals of some, shearing stresses will get developed. Shear stresses will develop. Some people will say how. So I hope you know torsion formula from your strength of materials, dear brother. I hope you know torsion formula. What is the torsion formula? T by torsional moment of T by IP is equal to QS by R is equal to Z theta by L. So when torsional moment is coming into picture, the shearing stresses are coming into picture. So because of this torsion, shear stresses will develop. So because of shear stresses are developed, when developing shear stress is more than design shear strength, design shear strength of material, then definitely that material will fail in torsion. That here that material is concrete, maybe RCC. That material will fail in torsion. To avoid such torsion, especially in beams, if you take a beam in this way, the torsions are more dominant at the mid layer and at the extreme layer. So at the extreme layers on the side elements, generally you need to provide skin reinforcement. So this is what is called as skin reinforcement, I can say. These are skin reinforcement. By the provision of skin reinforcement, resistance to torsion will be there, because if you take from the centroid here, more and more resistance to shear stresses are coming by coming into picture because of this reinforcing bars. These reinforcing bars are kept away from this from this CG. So because of which definitely, and the more and more CG, more and more these rods were kept on this side face. When the side face were kept, generally I can say moment of inertia about y axis will also get increased. And moment of inertia about y axis has also get increased, so definitely I can say torsional moment of resistance will also get increased. So how you can how the torsional moment of resistance will also get increased? When moment of inertia about xs plus moment of inertia about y are both are getting increased, then torsional moment of resistance will get increased. Here consider the moment of inertia, generally I need to consider because of these rods, right? Because of these steel rods only I need to consider, right? About this axis and about this axis, these steel rods are away with respect to x-axis and y-axis. This is nothing but skin reinforcement. Because of the provision of skin reinforcement, we are able to stop the failures of shear failures. I mean, we are able to stop the failures of torsion failures, right? Shabin Sailuddin. And of course, in addition to that one, shear reinforcement we need to provide, right? So that is end beams or L beams, and where you can see this torsion, brother, I can see this torsion also in case of beams curved in plan. Beams curved in plan, I can see this torsion. So these four aspects or five aspects are in limit state of collapse, and in limit state of serviceability, these are the things that are there. So can I rub the screen, dear Shabin Sailuddin? Dear Shabin Sailuddin, can I rub the screen? So coming to limit state of serviceability, limit state of serviceability, there should be sufficient guideline should be there how to reduce the deflections. If deflections are controlled, obviously cracks can be controlled and durability can also be achieved. So how to reduce the deflections? So in this case, they will give us the maximum deflection because of service loads should be less than limiting deflection. So that check we will say. And coming and the when I say constraint, when the limit state of deflections are satisfied, almost limit state of cracking is also not possible, and I can say especially durability can also be achieved, right? So this generally comes under limit state of serviceability aspects, right? So some people will say like, sir, okay, especially you tell me what is a design load, how you can define a design load. So how you can define a design load? Another name for design load is also called as ultimate load or factored load or collapse load or limiting load. All are one and same. Design load in case of from limit state limit state limit state method. How I can define this design load, brother? In case of limit state method, design load is equal to characteristic load multiplied by partial safety factor for forces or loads. This partial safety factor for forces or loads are there in IS 875 part 5 depending on load combinations. Depending on load combinations. I hope you know IS 875 part 5. Some people will also ask us, sir, what IS 875 part 1 deals with. IS 875 part 1, maybe part 1 deals with dead load. How to consider the dead load on the structure, that the self weights of the metals are given in part 1. IS 875 part 2, it deals with how to consider the live load on the structure. IS 875 part 3, how to consider the wind load. IS 875 part 4. It will deals with how to consider the what you can say snow load, right? IS 875 part 5. It deals with how to consider the design loads. Okay? Design loads by giving this partial safety factor for loads by using, maybe I can say, by using partial safety factor for loads, right? That partial safety factor, that is depending on load combinations. So for different load combinations, this this people call this as load factor in ultimate load. I am calling the same load factor as partial safety factor for loads or forces. So the terminology is different, but this is a synonym of load factor. Load factor, both are synonyms. Okay, both are same meaning, right? Now coming to, so here in the characteristic load, the synonym that we can say is service load. But this characteristic load, how we can define this characteristic load as per is 456, right? One second, I just want to convey as per is 456 how to define this characteristic load. So how to define this characteristic load? The load which has 95 percentage probability of it is scientifical way how you can consider the characteristic load. The load which has 95 percentage probability of not being exceeded in the life of a structure is characteristic load. So not 95 percentage, that load coming on this structure will not be more than this characteristic load. Only 5 percentage chance is there, like the load coming on the structure can be more than this characteristic load. That's what is the way how we can define. I hope you understood, right? So only there is a only a chance of 5 percentage chance is there, like the load coming on the structure will be more than the characteristic load, that is the physical interference. So that is indirectly in terms of scientifical way, that is only 5 percentage chance is there for load coming on structure or coming or acting load acting on structure is more than characteristic load. This is how scientifically based on probability it was defined, right? Okay. Now can I move to, I just want to show the same characteristic load with the help of a bell-shaped curve, because this is about probability. Na? By taking normal distribution, can I show how to work out that some people, especially Shabin Sailuddin asked, Sir, of course, forget about the terminology of strength. Strength will also be asked. Shabin Sailuddin asked, Sir, how to work out the mean load and come and mean load, how to work out this characteristic load. So I want to show that after I work out the loads, I will go to the strength as per Shabin Sailuddin words. Definitely. Can I move to the next slide, bros? Right? Is that okay? Yes. Right. This is how a bell-shaped curve I had taken. Here this F stands for what I mentioned about this characteristic strength, bro. If you just try to memorize that characteristic strength. So the characteristic strength, the load which has 95 percentage. This is the load which has 95 percentage probability. I hope you can see. This is the load which has 95 percentage probability of not being exceeded throughout the life of the structure. That load people usually call that the load by that point is taken as, I am taking it as F. And the load which has got 50 percentage probability that can come is called as Fm. I just want to say F, this is Fm. This is Fm. Maybe let me show with the help of eraser. This is Fm, right? Okay. This is FM and this is F. Oh, if FM is called as average or means, I can't say means, I average or mean load. If FM is the average load or mean load, if there are 20 observations that you can see on the load, like, so say a guy, especially our brother Devakar has done so many observations on the loads. He observed on one day the load acting on the structure is 20 kilonewton per meter. On another day, on the next day, it is 30 kilonewton per meter. Like that, he has made maybe 30 observations. Like from the 30 observations, I think Divakar brother can directly work out the mean load. How can you work out mean load? I hope you can work out the mean load from different observations as first load plus second load plus third observation load, fourth observation load, fifth observation load, nth observation load divided by number of observations, right? This is how Divakar bro can directly work out the mean load acting on the structure, right? The MFM stands for the mean load or average load acting on the structure. That average load, after average load means that average load means the load has a probability of 50 percentage chance is there for that load that can act on the structure. 50 percentage chance is there for that load to exceed beyond that load. That's what is the mean load we can write. 50 percentage, right? So I can say, okay, now I just want to write this F stands for, this is, this F stands for, how can you define this F? This is the load which has 95 percentage probability of not being exceeded, in the life of the structure, in the life of the structure, which we call that F as definitely as characteristic load, right? So characteristic load is definitely, I should get 95 percentage probability na? So load at 50 percentage probability plus this K stands for probability factor at 95 percentage level of probability, and S stands for standard deviation. S stands for standard deviation. This is how we can work out. And if you take this what you call, this bell shaped curve is following normal distribution. So if you refer to normal distribution, what is the probability factor, probability variate Z at 95 percentage probability? Z value of Z 95 percentage probability is 1.65. So that's the reason why generally this is from standard normal distribution. We are doing this, right? Praveen Kumar, क्या चल रहा है sir? Dear bro, यहाँ पे I am teaching you how to work out this characteristic load. Maybe how to work out. I had defined what is characteristic load का definition क्या है, मतलब क्या है, and how to work out that characteristic load from the definition of IS 456 I had teach you, right? प्रवीण कुमार भाई समझ में आ गया? मेरा हिंदी उतना अच्छा नहीं होता है, बट यहाँ पे जो कुछ हो रहा है, वी आर ट्राइंग टू डिराइव how to work out characteristic load from average load or mean load by using the concept of bell shaped curve, or by using the concept of normal distribution, which is purely mathematics from higher engineering mathematics. समझ में आ गया अभी क्या चल रहा है यहाँ पे, right? Right. Now, I hope you know how you got this mean load. FM stands for mean load or average load. I hope you are able to work out this one. F stands for the characteristic load. Na? So, characteristic load is mean load plus 1.65 times of standard deviation. Now, everybody will also ask us, sir, mean load I can easily work out in this way. It's not at all a problem. But how to work out the standard deviation? Dear Shabin Saluddin, some of the textbooks, actually, to be frank, one second. Yes, very good question, brother. To be frank, dear Shebi and Sehluddin, to be frank, exactly that value of jet factor is 1.645 is the correct answer. This is the correct value if you refer to normal distribution curve. Okay, instead of 645, if you want to be correct, if I want to say correct answer, 645 is the correct value. You can write, some people are rounding off it as 1.64, some people are rounding off it as 1.65. If you want to get a correct answer, use 1.645, brother. Okay, I hope I clearly mentioned the answer for Shehbin Sailuddin. Is that okay? 1.645 is the exact and correct value. If you want, you can use that one. Some people are rounding it off to 1.64, some people are rounding off it to 1.65. It's up to you. Some books are doing that way, some books are doing in this way. But 1.65, I consider, right? So is that okay? Now everybody will also ask us, sir, okay, out of the standard deviation, first of all, in the standard deviation, how to work out the standard deviation? I hope, maybe can I rub the screen, dear Shabin Sailuddin, bro? Can I rub the screen? Erase all the ink on the slide, right? So coming to this standard deviation, I can say this as sigma. I forgot to write here sigma. Sigma I is equal to 1 to n. Maybe I can write square root of sigma I is equal to 1 to n number of observations, 1 to n mean load minus ith load observation square by n minus 1. Is that okay? Right. Okay. Yes. So what is this FM stands for? Everybody can work out. FM stands for this one. You don't worry. We will work out a problem also. For everything, we will work out a problem. And FM stands for the mean load here. What is FI stands for? Ith load. Ith load. First, I stands for 1. F1 stands for first load observation. F2 stands for second load observation. Third load observation. F4 stands for fourth load observation. N minus 1. This is how you can work out this standard deviation. If you just substitute everything in this equation, we are bound to get the characteristic load from the definition of IS 456. Is that okay? Right. I just want to convey, in RCC, limit state is based on, in RCC, limit state is based on 95 percentage probability load. 95 percentage probability load. So because we are taking characteristic load, what is the definition? The characteristic load. So 95 percentage probability, the load coming on the structure will not cross that characteristic load. Right? That's what we mentioned. So RCC limit state is based on 95 percentage probability load. Right? So some people will also ask us, similarly the same type of thing we had taken in pavement design, sir, in our what you call traffic, I mean in our highway engineering, we had taken the same type of characteristic load, sir. But the characteristic load there we had taken for pavement design is based on 98 percentage probability load, right? So I can say, in pavement design, especially in your highway engineering, you might have studied for pavement design. For pavement design in highway is based on what percentage of probability load? 98 percentage probability load. I just want to make you understand, there in that particular thing they had taken the limit state as 98 percentage probability load, here 95 percentage probability load. So different tests on concrete is included, like split tensile strength, etc, definitely, but not here. This is just an intro part, na dear brother. Here I am not discussing any tests on split tensile strength, how to do. But anyway, you can work out that split tensile strength here. It's very easy. 1 second. Maybe if you had any doubt, you can ask us. If you work out, if you can keep a cylinder in this way, and if you are able to apply a load in this way, the failure load is P, then the split tensile strength is 2P by pi LD. So of course, anyway you can easily work out, but those tests I am not discussing. My intention here in this thing is, in introduction, if I teach about test, that will be completely into concrete technology, that will be completely into material testing side. I am not going to the material testing side. Material testing side, your teacher especially may, I may tackle at the time of construction materials and management, I will tackle. Okay, my research is also entirely into concrete. I can screw the concrete like anything, it's not at all a problem. I will tackle this test at the time of concrete technology, especially in construction materials. In materials I will tackle. Okay, right. Is that okay? Right. Okay, 1 second. Right. Now coming to some people will say, sir, this is the question or example. Some people, especially Shebin Sailuddin or Ambar Datta bro or Mr. Devakar bro or Praveen Kumar bro will ask us, sir, can you give us a small example how to work out the characteristic load? Let us suppose our Devakar brother has made five observations, and five observations of loads acting on the structure. This is the first observation made by Devakar, first load maybe F1. This is the second observation made by Devakar, maybe on some other day. This is the third observation made by Devakar on some other day or at some other F3. This is the fourth observation made by Devakar on some other day. Fifth observation made by same Devakar on some other day. Actually, to be frank, to work out characteristic load, at least minimum 30 observations of loading should be possible. So please understand. But as an example, if I take 30 average, that it will screw the calculation. So I am not going for that one. Just to make you understand how to work out the characteristic load. Characteristic load is mean load. That is the load. How you can define the characteristic load? The load which has 95% probability of not being exceeded throughout the life of the structure. So which is FM, mean load, 50% average load plus Z factor, which is 1.65 times of standard deviation. This mean load is how much, brother? 32 plus 1.65 times of standard deviation only I need to work out. So can you work out standard deviation, bro? How to work out standard deviation? I had given to you sigma of F mean load minus ith load observation square by n minus 1. How many number of observations of loads are there, brother? Here 5. Na? So I can say square root of this denominator is I is equal to 1 by 1 to 5. I can say n by 5 minus 1. I can say here the first mean load. Mean load is how much, man? 32. 32 minus first observation. 32 minus 30 square plus 32 minus 15 square. That means Fm minus F2 square plus Fm minus F3 square. So Fm is 32 minus 20 square, maybe plus Fm mean load is 32. 32 minus F4 square. 32 minus 45, it seems. 45 square plus Fm is 32 minus F5, 50 square. If you are able to do in this way, na bro, definitely you are bound to get the standard deviation, and the value of that standard deviation is 15.24, right? So in this case, what is the characteristic load you need to consider? 32 plus 1.65 into standard deviation 15.24. You are bound to get this one as 57.16 kilonewton per meter. So this is the load that you need to consider. This is the characteristic load you need to consider. And if you want to consider the material factor of load factor of safeties for loads, I can say a partial safety factor for loads. This multiplied by 1.5 again. That will be the design load, right? That will be the design load. I hope you know the design load here, right? Design load, right? Can you see this design load? FD stands for design load. Maybe let me erase. Design load is equal to characteristic load multiplied by this partial safety factor for loads or forces. Generally, if it is dead load and live load combination or anything, it can be treated as 1.5, of course. So in our present example of characteristic load, it is 57.16 into 1.5. That much is the design load for which I need to design the structural element. Have you understood that concept, right? This is how you can work out the characteristic load. After you work out the characteristic load, you can work out the design load also, right? Yes. So can I move to the next question, next concept? Some people will say like, sir, you mentioned this characteristic load, okay, but you need to mention about this load factors. Or some people will call us, sir, you need to mention about the partial safety factors for loads. Yes, I need to teach you about the partial safety factor for loads based on IS 875 part 5. IS 875 part 5, right? So I want to go to that. So I just, before I go to that one, I just want to give as per IS 456 2000. Please let me read. As per IS 456 2000 code, right? So to have characteristic values, minimum 30 samples are required to have proper correlation. So I need to observe minimum 30 samples. I need to observe minimum 30 observations are there to work out characteristic values, right? So shall we go to I just want to convey one more thing, right? I just want to convey, some people will also ask us our design load combinations, design load combinations. For limit state of collapse it is different, and for limit state of collapse it is different, and for limit state of collapse, design load combinations are different. For limit state of serviceability, design load combinations are different. Okay, so let me write the design load combinations, including load factors or partial safety factors of loads for limit state of collapse separately and for limit state of serviceability separately. For limit state of for desi- uh, design load for collapse, design load for limit state of collapse. Maybe I hope everybody can say, sir, if it is a combination of dead load and live load, then in such case the load factor or partial safety factor for load is 1.5. Na? So generally we can use 1.5 times of dead load plus 1.5 times of live load. Second one. So, sir, some people will say, sir, if live load is not acting, only dead load is there. Dead load and wind load are acting. In such case, I can say 1.5 times of dead load plus 1.5 times of wind load or earthquake load. Maybe you can use, if in case of EL, earthquake load, I can say I am writing in terms of earthquake load. Out of earthquake load and wind load, whichever is high, I need to consider that one in this combination. So 1.5 times of dead load plus 1.5 times of earthquake load, or I can say wind load, whichever is max. Whichever is max, I can consider. So that this is R, okay. And I can say some people will say, sir, in addition to dead load, live load, even wind load or earthquake load is also acting, sir. In such case, the load combinations are 1.2 times of dead load plus 1.2 times of live load plus 1.2 times of earthquake load or wind load, whichever may be the maximum one. These are the three load combinations generally I need to consider. Some people will also cry at me like, sir, wind load and earthquake load, both these two things can happen at a time. No, I just want to say till now, whenever earthquake is coming, by the time heavy wind was not blown because of cyclone, whenever by the time cyclone was coming because with heavy wind, by the time earthquake has not occurred. So please understand, when a natural calamity has occurring, two or three natural calamities all together will not occur. If you design for that stuff, then government of India will lose all its funds. If two or three natural calamities, till now in history, no time two natural calamities has occurred at a time. So please understand that. So that's the reason why I can say, like, when earthquake loads are critical, I cannot consider wind loads. When wind loads are critical, when wind is happening more, by the time earthquake will not come. So both these two natural calamities will not occur at a time. So please understand that, right? Okay. So right now, this is the design load for collapse. Some people will also ask us, these are design loads for limit state of collapse. Okay. So some people will also ask us, sir, can you is, sir, but it is possible, sir. It is not possible till now in history. It has not happened in this way. Even if it is possible, even though if you construct both cyclone and earthquake, both has got happened. In such case, as the section size is very 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 high, nobody cannot afford that much structure section size. Government of India will lose all its funds. Moreover, till now in history there is no record both earthquake and both cyclone has came at the same time in the same place. It is not possible. Sir, why in yes, right. Shabin Sailuddin. Dear sir, in third situation, so why 1.2 is taken? Dear brother, I just want to say here, maybe some people are asking like, sir, why you are taking here 1.2? Here you can understand this load factors. 1.5 is the load factor, or I can say partial safety factor when the combinations of dead and live loads are combination. When it's the combination of dead load, live load and earthquake load, if you had gone for the load factor is 1.5, after observations of so many trials and after observations of so many observations, as with models, they understood like 1.5 is not required here. Here three different loads we are considering here na. So just 1.2 itself is sufficient. So many trials based on model analysis, they finally fixed the load factor here, that is fitting is 1.2, because the loads acting are not just two loads, dead and live loads. The combination is dead load, live load and wind load or earthquake load. Three different types of loads are actually acting together as a combination here. So that's the reason why I can say here it is 1.2. Right, right, right. Okay, okay. Umber says okay, okay, right. Okay, right. Sir, S is equal to 10.45 in your previous topic. Okay, you are talking maybe S value. Maybe that S value is not 2.4. Dear, I hope you can understand. This is not 2.4, it is 15.24. Okay, within my calculation, I got it as 15.4. It's not at all a big deal, bro. But dear Shabin say, Mr. Devakar, bro, I hope have you taken the square root also? Square root, this is divided by 5.1. This is plus, right? This n minus 1 is only at the bottom, which is 4 divided by 4 whole under root. Okay, whole under root. I'm pretty much sure like this answer will be 15.4 only, because I had clearly worked out that, right? It's not at all a problem, brother. Dear Devakar, you can work out that again. It's not at all a problem. Okay, that is an example, don't worry. Of course you can work out, but the answer is same, but the answer is correct. Now, these are the design load combinations for limit state of collapse. Now, our brother Devakar bro will also ask us, sir, can you tell us what are the design load combinations for limit state of serviceability also? Yes, for design loads for serviceability, we need to consider. I can say design load for service. For service means here I need to consider just service loads or working loads indirectly. Whatever may be the actual loads, I need to consider that indirectly. So here for what are the load combinations? The load combinations for design loads for service: one times of dead load plus one times of live load. Second one, maybe I can say dead load live load combination is over. Dead load and earthquake load combination, I can say one times of dead load plus one times of earthquake load, I can write. Third combination, I can say it is the combination of so some people will say, sir, earthquake load or wind load all shall I write? Yes, earthquake load or wind load, whichever is higher we can consider generally. So I can say third one, I can say is one times of dead load plus zero point 0.8 times of live load plus zero point 0.8 times of earthquake load or wind load, whichever is higher. So when I am writing, see here, in case of earthquake load is replaced by wind load, in earthquake load combinations for partial safety factor. Where let us suppose when wind load is 25 kilonewton per meter, earthquake load is 32 kilonewton meter. In such case, you need to use the maximum of these two. So let me write here clearly. Maybe clearly I can write here as earthquake load or wind load. Earthquake load or wind load, whichever is high, you can take. Earthquake load or wind load, I can write. Sir, why 1 instead of 1.5? Shaybin Sailuddin. Dear Shaybin Sailuddin, I already mentioned here there is a terminology called as service. What is service loads? The actual load that is coming on the structure. The actual load that is coming on the structure itself is characteristic load. In such case, the characteristic load multiplied by how much could be the load factor? The load factor should be 1. So because of service loads or working loads only, we are working out. So what do you mean by design loads for service loads? The actual loads, because that are actually coming, we are not exaggerating here. That load factor or partial safety factors are mostly 1. Here it is 1. Here it is 1, because whatever may be the actual characteristic load, I want to take that itself directly, right? That's the meaning of 1, means that partial safety factor is 1. That means whatever may be the actual load, the characteristic load or working load, directly the same thing we are considering. That's what here I mentioned clearly. We will use here only service loads or working loads or actual loads. Maybe I can say actual loads. Maybe here I can say acting on structure without any load factor. I can say if there is no load factor, when there is no load factor, that load factor is almost 1 na. So that's the reason why here I am writing 1 times of dead load, 1 times of live load. Is that okay? Right, these are the three things. So whenever so I hope you can I rub the screen? I hope you had taken these three, right? So can I rub the screen? There Shebin Sailuddin, Mr. Devakar, Ambar Datta bro, or any other person who are on the online, right? Can I rub the screen, brother? Right? Right? Right. Yes. Okay. Okay. I just want to give, some people will ask us, sir, how to work out the design load for which in collapse, how to work out the design load in serviceability separately. Can you give an example? This is an example. Maybe our Divakar brother will ask us, like, sir, provide some example. This is an example for you guys. Example, maybe the dead load is 150 kilometer meter, live load is 250 kilometer meter. W stands for wind load is 25 kilometer per meter, EL stands for earthquake load is 32. So generally by the time of wind load or earthquake load, out of these two, whichever is higher, I need to use that one. So please be aware. So now the question is, calculate the design load in collapse separately, calculate the design load in serviceability separately. Can I do that for you? Right, I hope you had taken this data with you: dead load, live load, wind load and earthquake load. Can I show that how we can work out? This is how we can work out the design loads. Okay, this is how, this is design load for collapse. This is the heading. So three design load combinations I had used. First design load combination, 1.5 times of dead load plus 1.5 times of live load. I just substituted 1.5 times of dead load plus earthquake load or wind load. Out of these two, whichever may be the max, I need to use. So what is earthquake load is how much, what is wind load is how much, bro? I hope you can see the wind load is 25, earthquake load is 32. So wind load is uh, wind load is 25 kilonewton per meter, earthquake load is 32 kilonewton per meter. So out of these two, whichever is maximum, I am using that one. The maximum one is earthquake load na, so I am using that earthquake load, which is 32. So that's the reason why I got this value. Okay, so it is 1.2 times of dead load plus 1 point live load plus 1.2 times of earthquake load. Here earthquake load, to be frank, here I should write earthquake load or wind load, whichever is max. By the time I am considering wind load, earthquake load will not come. By the time I am coming taking earthquake load, wind load will not come. Right. So out of these three, so what is the maximum value? That maximum value, use more of the three values. You use higher of these three values. What is the higher? Here 600. Here it is 273. Here it is 518. The higher value is 600. Na? So the design load for collapse, the structural element will be designed for a load of, structural element will be designed for a load of maybe 600 kilonewton per meter. Right. Okay, okay, man. I just want to say some people will also ask us, okay, right, sir, what this is so the design load for collapse is 600 kilonewton per meter. That will be the answer. Now, some people will also ask us, especially our Divakar bro will also ask us, sir, what is the design load for service, limit state of service, serviceability, service in sense for limit state of serviceability, limit. This is for limit state of collapse. Right. Sir, design load for collapse is the characteristic load. No, these givens are characteristic loads. Dear brother, these given loads are characteristic loads. Design loads for collapse. See here. Design load for collapse or anyway, it is always characteristic load multiplied by partial safety factor for load. I can write. Or I can say partial safety factor per load. The same thing can be called as synonym word for this one is load factor, right? The load factors for limit state of collapse. The load factor for limit state of collapse is here. These are the load factors clearly. These are the load factors. These are the load factors. Or I can say partial safety factor for those. What are the load factors for limit state of service? These are the load factors. That means in for service loads generally the design loads generally are generally the service loads or maybe the working loads. Generally, as a comment, generally design load, design load. One second, design load for limit state of serviceability or characteristic loads, as almost load factors are almost how much? Load factors are almost 1, right? So that's how you can understand here. Here, here the load factors are high, here the load factors are 1, right? Is that okay? Dear Shapin Sailuddin, whatever you wrote, that is a wrong one. Okay, it is not just characteristic load, it is always characteristic load multiplied by load factor, or in other words, characteristic load multiplied by partial safety factor for loads or forces. Okay, right. Moving to the next question, maybe I can say, so today the time is already over. So please excuse me for today. I am just stopping the session. Is that okay? Of course, few slides are there, 4 to 5 slides are there. We will work out those 4 to 5 slides in the next coming session from tomorrow's session. Is that okay, brothers? Right. So I just want to say, like, if you are a serious aspirant of GATE and ESE, then I can definitely recommend you to take this paid course. And this paid course, if you are able to use this code VT10 direct, definitely 10% discount will directly come to you. That is one thing. And in the 12 months, if it is a 12 months course after 10% discount, I can say the cost is 27,225. When it is an 18 months course, after 10% discount, the cost is 34,650. When if it is a 24 months course, after 10% discount, the cost is 39,600. I can say one thing, right? While you are using this code VT10, it will directly connect between you and me, and moreover, it will provide 10% discount to you on all the courses in Unacademy Plus, maybe from 6th standard to the PG standard. So if you are a serious aspirant, if you want to crack GATE, ESE, or any other competitive examination, yes, sir, will this PDF in Telegram? Uh, will this PDF will be on Telegram? No, I don't think so. This PDF I cannot keep in Telegram because of company constraints. I cannot give. But if you had any doubts, you can keep your doubts, post your doubts directly there in the Telegram group, and I can answer your doubt. It's not at all a problem. Okay, right. Okay, right. So every day my class is happening by 11 a.m. in this Let's Crack Gate ESE and Civil YouTube channel. So please take use of this one every day. My class is also happening in Unacademy learning app for free of cost every day by 5 p.m. So okay, so please take use of that one also. Come down to that Unacademy learning app also. In that one, special classes of mine are there, so you can take use of that also, right? So I can say finally, please share these videos to more of your friends. Please like these videos. Please, and moreover, YouTube comments are also welcome. And if you are a serious aspirant of GATE and ESA, I can recommend you to use this code VT10. When you use this code VT10, definitely 10% discount will directly come to you on all the courses. When you use this code, definitely VT10, right? And this is the name of the channel, which is Unacademy underscore Civil Engineer Tilak. This is the name of the channel. And you if you want to join this channel, please press this link here. It will redirect to my channel. And if you come down to my channel, then you can ask me the doubts. So that is for free of course. So thank you, end of the session. Thank you.